Welcome back. This is number 2 on the specific heat capacity notes. So I've listed my given and my need. I've also kept the equations on the board from problem 1. And I did something that is helping a lot of you guys. So in this question, I'm solving for TF, but I'm going to have to go through delta T to do that. So I'm going to rearrange my specific heat question, my specific heat equation for delta T. That way, once I plug in, I'm just dividing. I don't have to move units around it or any of those kinds of things. It seems like that's one of the biggest things tripping us up right now. So once I get to this point, kind of my thought process is if I can get to delta T, then I can plug into this equation with my known temperature, and I can figure out the other one. I can do subtraction and figure out what temperature what temperature final must be. So I'm going to solve this. I have solved this for delta T. I'm going to plug the numbers in, and then I'll use that to apply to my delta T equation. So I've got the Q this time. I've got 455 joules. Good, you can read that. Over my mass was 150 grams. 150 grams. Just like last time, I'm not going to track my 10 through it because that's extra information. And then multiply by my specific heat. So that would be times 0.217 joules per gram degrees Celsius. Okay, so let's do some unit cancellation. We've got grams and grams on top and on bottom. Then we got joules and joules. That'll cancel. Then my Celsius moves up top. That all equals delta T. So delta T, when I do 455 divided by the quantity, 150 times 0.217, I get 13.98 degrees Celsius. So that's my delta T is 13.98. So I know from my equation, let me switch colors here so we can see it a little bit better, that delta T is temperature final minus temperature initial. Well, I'm looking for temperature final, so let me solve the equation. I'll take my delta T plus temperature initial equals temperature final. All right, so I've got my temperature initial and I've got my delta T. So let me plug those in. Delta T was 13.98. And my initial was 22.3. So my total ends up being 35.91 degrees Celsius. So you might have noticed that I was stumbling through my math, and then I paused, and then quickly I broke. So I did the math wrong. My answer key, I missed a decimal, so my addition was wrong. So my final answer should be 36.28 degrees Celsius. So that's just a different way to apply specific heat to solve problems. Just again, same formulas, just applying them in a slightly different way.